The CRADL project is a project that's aiming to get EIT as a monitoring tool into clinical practice. The CRADL device, it's only a very small textile band that we're using. The information that we are mainly interested in is how the aeration of the lung is. When we support babies who have problems breathing, the main objective is that we get an even distribution of the air into the lung, and we don't have any tool at this point in time to measure this.
With EIT you can gain the information on how the lung functions directly at the bedside. You don't have to transfer the patient, you don't have to use radiation, you don't have only a limited information at one certain time point, but you acquire the data continuously. So this is a big benefit of EIT, and it's not difficult to use.
At this stage we've got a mocked up interface that the clinicians can look at that is our dream for the future. Hopefully clinicians don't need to translate the data because we've done the translation for them. EIT produces voltages. We give the clinicians information on, is the lung overdistended? Is the lung filling properly?
If you can measure all the voltages and currents on the surface of the body, and that's what we do with the EIT instrument, and then one can prove actually mathematically that you can also calculate what's inside. So there is a mathematical foundation for the algorithms, and in principle these algorithms can give you an infinite resolution. So what we are trying to do in the project is to push the limits as far as we can, improve the imaging by making better electronics, better measurements, but also by doing better models.
Swissdom is responsible for the commercialization of the EIT device to bring EIT into the market and to the clinical end users. We're going to conferences and we're showing our device. We discuss with doctors and nurses what information do they need to be displayed and how does the product should look like.
The technology that we're developing here is to provide new information, not simply duplicate information they can get from other technologies. Part of that process is that we need to deal with disseminating how EIT works, what it can provide to neonatologists and its usability.
What's left to be done is to continue to look at those two critical aspects of performance, which are electrocontact and developing new ways of achieving that, and the shape reconstruction technology, and make this into a useful product for medics and clinicians that's workable in that clinical situation. And some of the fascinating things as a product designer to bring all of that together.